It turns out that we have seen some examples of subspaces that are spans of other vectors already. For one, any matrix A, m by n, m rows, n columns, if you find the solution to A times x equal to 0, then that solution turns out to be a subspace of Rn. For a couple of things, we can note that the solution does contain 0 because A times 0 equals 0 is true. So whenever you have a homogeneous equation like that, the 0 vector is one of the solutions. But it might have some free variables too. It might just be 0, might have some free variables. Either way, we call the whole solution the null space, N of A, or sometimes spelled out null of A. So let's find an example and see what it looks like as a span. Find the null space N of A for this matrix A, 1, 0, 0, 0, 0, 0, 2, 3, 1. Now, it's the same question as solve AX equal to 0. So you just augment with the 0 vector, or solve the homogeneous equation, or even you can go back and think of it as a vector equation or a system of equations. Either way, you put the 0, 0, 0 on at the end of the matrix and row reduce. So this one is not too hard to row reduce. It's almost there already. All I did to finish it was to take row 2 and subtract 3 of row 1, and then take row 1 and subtract 2. Oh, sorry, row 2 and subtract 3 of row 3, and then row 1 and subtract 2 of row 3, and I get it into this form. It may not be quite in reduced row echelon form. To get it in reduced row echelon form, I need to switch the last 2 rows. But actually, it won't matter much for writing down the solution. So I went ahead and just wrote the solution down to save myself a second. The only other thing to do would be move that row of zeros to the bottom. As it is, you can already read it off. You can say x1 is equal to 0. x2 is not a pivot column. It's got a column of all zeros, and so it's just a free variable. And then x3 is equal to 0. So the solution x vector is equal to x2 times the vector 0, 1, 0, the coefficients of x2 on the 3 answers. There is usually sometimes a step where you have to solve some more, moving everything to the right-hand side of the equation, except for x1, x2, and x3. It was already in that form, so we were set. So the only new thing to do is to write down that our answer is the null space of A, and it equals the span of 0, 1, 0. It's any scalable multiple of that. Just another way of writing the same answer we already had, but it's a new way of thinking about it, since we can think of it as a subspace. Where B is equal to this matrix has 2 rows and 1, 2, 3, 4, 5 columns. So I augment with zeros again and solve the big matrix with 0, 0 at the end. And again, there's not much work to do. That's because there's no way to get rid of most of those numbers. I'll just divide the second row by 3, and to get the 1, 2, 0, -1. 0 is where there used to be a 0, because 0 divided by anything is 0. Then I'll take the first row and replace it with itself minus 2 times the new row 3. So I'll have 2 minus 2. I'll have 1 minus 4 is -3. I'll have 0 minus 0, and I'll have 3, or I'll have 1 minus -2. So 1 plus 2 is 3. So yeah, I have to be a little careful doing some of that in my head, but it looks right now. And that's row reduced echelon form. Can't do anything else. I have pivots in both of the rows. So I'll turn it back into equations. So now I have x1 minus 3x3 plus 3x5 equals 0. x2 plus 2x3 minus x5 equals 0. Now, each of the columns corresponds to a variable, and it's 5 columns, 1 through 5. And then the other columns where there were no pivots are all free. x3 equals free variable, x3, x4 equals x4, x5 equals x5. Now I do have some work. I have to move everything to the right-hand side of those equations except for x1, x2, x3, x4, x5. So add the 3x3 and subtract the 3x5, add the 2x3, or subtract the 2x3 and add the x5. And then now I can write the answer as a linear combination. The vector x, which is x1, x2, x3, x4, x5, is equal to, and I'll take out each of the free variables in turn. x3 has coefficients 3, -2, 1, 0, 0. x4 has no coefficients except for one spot where it was itself free variable, so it's 0, 0, 0, 1, 0. And x5 has all those coefficients, -3, 1, 0, 0, and 1. So now that I've done that, I can write the final answer not as a linear combination, but instead as a span. The null space of B is equal to the span of those three vectors, 3, -2, 1, 0, 0, and 0, 0, 0, 1, 0, and -3, 1, 0, 0, 1. So there's a lot of ways to writing the answer. Once we could write them as all the equations, the second group of equations, or as a linear combination of vectors, or as a span. And that's important to be able to do all those, so you have to read the question sometime to see what they want. Are they asking for the answer as a span or a linear combination? And next we'll look at the further examples.